Anyway, thanks for having me, guys. My name's I'm Tim Oliver, and I'm from a company called Realm. And today I'm going to talk to you about. I'm going to share with you a bit of a story about my amazing journey with all the databases that iOS has for local storage before up into Realm. I'm going to talk about Realm for a bit. From what I've heard, there's a few people who actually let's have a show of hands. Who's heard of Realm before? Oh wow, that's a lot of people. That's like 3/4 of the room. Who's used Realm before? Well, that's still a lot of people. Okay, that's half the room. Who's shipped an app using Realm before? That's good. That's about a third of the room. Nice. Okay. I think my work here is done. Yeah, and then finally I'm going to talk about the new. So that was step 2. I'm going to do a quick for the people who haven't actually used Realm before, a bit of a ramp up into how the API works, what some of our kind of like methodologies are, and then for the third point, I'm going to introduce the new hotness we announced about not even a month ago called the Realm Mobile Platform. So who am I? I'm from Perth, so I'm in the same time zone as Singapore, so I'm kind of in the neighborhood most of the time. But at the moment, I'm actually hanging out in San Francisco, which is really cold at the moment. I studied joint computer science and multimedia at university in Perth, so that was an interesting experience because it was kind of like doing database design for one half of the week and then do like Photoshop and Flash animations the other half of the week. I used to do web development until 2013. And then I moved to full-time iOS development in 2013. I spent a year in Japan working at an iOS company there, which was really good fun and really hard in certain languages. I love building apps in my free time, and I love I like open sourcing the components of my apps to give back to the community. I actually had a nice gentleman come up and tell me he actually contributed a PR to one of my open source libraries, so thanks for that, Kevin. That was really good. And I also love karaoke and video games, so if there's an after party after the after party, let me know. Anyway. So, let me just give you a quick history of my all the dickening around I've done with apps and databases. Back in 2011, I made a very, very copyright infringing app called iPokédex, which is basically a completely offline index of every single bit of Pokemon data you can have. It's very useful when you're on the train and playing Pokemon on your DS, and you need to know what level Pikachu learns Thunder at, so you don't evolve him into Raichu before he learns that, because Raichu can't learn Thunder. You know, very non-nerdy stuff. So I was thinking about using JSON, but JSON would have been terrible because the Pokemon dataset is not small. So I decided on SQLite. So I basically aggregated a bunch of data from a huge number of Pokemon websites into a SQLite file, and then stored that as a read-only bundle in the app. And this is a long time ago. This is iPhone OS 3 times. So there was no GCD. It was all NS threads and all that, and no ARC. It was the dark ages, truly. And basically what would happen is I'd implement a model where you would do a query of SQLite and then pull that data out and put it into basically a manual NS object subclass. But because SQLite is like a copy operation, that means you have to be very careful about how much data you have in memory. And back on the iPhone 3G, you had a flagrant 128 megabytes of RAM to work with. So a lot of string data was actually a really big deal. So I actually had 2 versions of each object, a light one for table views and then a detailed one for actual detailed view controllers. And yeah, there is a ton of data. Like just the Pokédex text is like 20 megabytes across every game. It's ridiculous. Now, the cool thing about SQLite is there's a lot of tools out there where you can generate databases from scratch. So this is basically what the internals of it look like. It was a lot of tables and a lot of data. But the app worked, and it was pretty performant on an iPhone 3G, and it was good. It was pretty decent. So I had a few takeaways from SQLite from that experience. Because SQLite is a C library, there's always this kind of necessity to have some kind of bridging code that will make the experience of using a C library in Objective-C or Swift nice. You can write that yourself. There's a ton on GitHub as well. But again, it's not a native experience. There's always some kind of intervention you need. Because of that, in addition to that, SQL is not a normal skill you need for writing iOS apps. You need to know what a primary key is, what a foreign key is, how to index columns properly, how the structured SQL language works, like select star from database and all that. So there's another level of skill and knowledge you need to have to actually get this to work. And again, like I said earlier, you have to take data out of a query and then map it to an object in order to work with it. Like to have it in a table view, I need an array of objects I can work with. So there's a lot of effort to actually map data from a SQL query into a usable format. And again, because you're actually copying data from disk into memory, you also have to worry about things like how many entries are in memory at once. You have to have this thing called pagination most of the time. Anyway, and the last thing is obviously SQLite is very manual. You have to execute a query to generate the database, and then if you want to change any schema, it's another set of queries you have to execute. So it's a very manual process. So it works, and it's a pretty decent solution, but it's it's a lot of time. The next app I made is it's a DRM-free comic book reader called iComics, and I've actually been checking out IG Listkit for this. It looks very nice. Basically, the idea of this app is you have all those comic book apps that are walled gardens like Marvel and DC, where you have to buy their comics inside the app, and you can only read them inside the app. But there's a lot of comics on the internet, like the indie, like Humble Bundle, and a lot of DriveThruComics.com, where they give you the comic, but there's no app. There's no like complementary app you can use it to consume on your iOS devices. So the point of this app is kind of like an open like any comic can be put into this and read. Obviously, this one I actually used Core Data for originally. I was coming off SQLite, and one of my friends said you should try Core Data. I needed some kind of data persistence solution for this thing. Because transforming, a lot of the time, a comic book is literally just a zip file of JPEGs in it. So transforming that into a usable kind of like medium requires a lot of like pre-processing. Most importantly, pages aren't organized in a zip file, so you have to manually go through and generate a list, page1.jpg, page2.jpg. That needs to be stored somewhere. So Core Data was touted as like, it's like SQLite but less effort. And I was like, that sounds nice. You know, you can do, like it gives you managed objects. You don't have to do any manual copying between SQLite or your objects. Schema migration is done for free, so that's a lot of less effort. And you don't actually have to know SQL. Like you can actually do like native NS predicate fetches to actually get a pretty good experience with a lot less effort. And of course, it's a native framework, you know, supported and loved by Apple and proven to be bulletproof and everything. And yeah, so it must be good, right? Well, no, this is basically my experience on it. It was basically a year of pain and suffering. But actually, that's pretty much what it looked like when I program anyway. But yeah, it was not fun. It was not a good experience. Core Data is pain. Basically, the takeaways I had from that was it's a lot of effort to learn. You have to know these things like NS persistent store coordinator and NS managed object context, NS managed object. You have to know what an XC data model is, and then that's before you even actually write any code. And then you have to write a ton of code to make all those little elements work together. So it's a lot of effort before you can even start saving stuff to disk. And if anything goes wrong, because it's an Apple framework, you might get a cryptic error, but you have no idea what's going on. It's kind of depressing and soul-crushing. And again, you're not really getting any benefits because it's built on SQLite, you're still getting like the memory copy issues. So you still have to worry about things like faulting things into memory now and again, and just making sure that you're not going to overrun your available memory. And the thing that killed it for me eventually was if the automatic schema migration of Core Data doesn't work, it kind of just half blows away your database. So you've got a half-working database, and that makes the app perform in ways I never thought it would be able to. And the scenario I had was I had a shipping version on the App Store, and I had a new version in beta, and all the beta testers were saying, like, what did you do? Like, this thing is terrible. It's doing all sorts of weird crashes, and half of my comics are there, or the comics are there, but the thumbnails are gone. And I was like, what's going on? And, oh, it's Core Data. Okay. So I basically hit a point where I was like, that's it. Core Data I'm done with this. I'm spending more time debugging Core Data than I am writing code. So what can I do? I was this close to going back to SQLite, knowing it'd be more effort, but it would at least be a bit more stable. When I heard about this thingy called Realm, and I was like, Realm, okay, that's an interesting name for a database, okay. So I went to their website. The website looked like this back then. It was, they were operating in stealth mode at the time, so it was a very dark color scheme. You know, because databases are in the background, you know, they're in the shadows, you know, they're not really in the front facing of the UI. And so I basically said to myself, well, all right, what the hell, my app is now unshippable, so I'm going to just tear Core Data out and stick Realm in it. And I'm sure Realm can't be as bad as Core Data. So to do that, I set aside one evening. I was like, I'm just going to do a little hackathon, and we'll see how far I get in one evening. So to convert a completely Core Data app to Realm, I just changed all the NS managed objects names to subclass names to Realm object names, basically the exact same thing. I got rid of all the NS number properties in my managed objects because Realm actually does native like ints and CG floats and doubles and all that and booleans. That was actually quite nice. At that point, the code stopped compiling because it was obviously a huge mismatch. So then it was just a matter of going through every single build error and figuring out how to replace the Core Data fetch and save operations with what Realm has. I didn't need to do this because I knew that the data could be regenerated next time the app was open, but some people have actually implemented ways to, without using NS managed objects, like pull the data directly out of Core Data and move it to a Realm instance. So it's pretty straightforward, and there's lots of good tips on the internet how to do that. And it took like 3 hours. Like I just like went through it. I hit build, and I was like, this is going to be crap. It's not going to work. But it just worked. And I was just like, what? And so I was like, what the hell? This is goddamn amazing. So, and yeah, so after that, well, I kind of joined the company, and yeah, it's been, thank you. And it's been ridiculous and amazing ever since. Cool, so that was the first step. So now, let's talk about, if anyone hasn't actually used Realm yet, let's talk about really quickly how the API works, and basically we'll go up a bit more levels into some more advanced things like how to actually use it properly and how to actually make it work efficiently. So what is it? A lot of people think we're just SQLite still, and we're not. That's a huge misconception. It's actually a completely custom C++ engine designed by two engineers who used to work for Nokia, and they bashed this together in their free time and thought it was pretty good, so they took it to Y Combinator and managed to make a company out of it. As a result, it's not structured like SQLite at all. Like, it basically treats everything inside it like objects. So you're basically not doing any data transformation between how you're working at it with your own code and how it's saved on disk. It's just objects all the way through. Another cool thing about it is it uses a lot of interesting memory maps techniques to provide a zero copy experience, which means when you have an object you're working with in your own code, you're not working with a copy of your object, you're actually using a pointer that's pointing straight to the entry memory maps to disk. So you're actually getting a very nice, fast experience because there's no overhead of copying and there's no actual memory consumption happening. So while it's a C++ core, which we call the core, it's actually, what we do is we provide Objective-C and Swift frameworks, encompass it and provide a native framework, so it still feels nice to work with. So you get rid of that kind of SQLite feel of needing to implement your own bridge for it. It uses a lot of the cool internal ultra-hacky Objective-C runtime reflection techniques to basically do a lot of method swizzling and property access in the background. So a lot of it from the front face is basically auto magic, and there's not much you have to do because it does a lot of smart things in the background to set itself up. And the cool thing is it's completely free and open source. The core and all the bindings are available on our GitHub account under the Apache license. So what is the Realm Hello World app look like? It's a ton of code, so get ready for this. It's basically just that. So I can walk through this really quickly. Is this going to laser? Yeah, lasers. Okay, cool. I'll try and speak in the microphone. So basically there's 4 important steps to this. First one is you import the header. That bit's really important. Second bit is you define an object, and this thing is what actually gets saved to disk. So basically this is an encompassing object and every property is persisted. The dynamic keyword is very important because that is required to work with the Objective-C reflection system. The next step is you create a new object from scratch, and then you fill out the data, and then at the bottom you reference an object called just Realm, and you basically open what's called a write transaction, and you then just add that dog reference to the Realm, and that's it. That's all you need. So if you were to execute that in your app, and then check out what actually got written to disk, if you go into the documents directory of your app, what you'll see is a file called default.realm, and we provide an introspection tool called the Realm browser, and right there, as you can see, the properties we put out were saved to disk. So that's a lot less code than core data. Like, core data would have been like at least 100 lines to get started. That was like, I don't know, like 3, 4. So it's nice compared to core data. And basically there was only 2 objects we really worked with just there. There was the Realm class, and that basically represents .realm files in disk. It's just a context for reads and writes. It's nothing special, it's just, that's how you actually know where you're actually writing to disk. It can be configured, like if you don't want it to be saved to the documents directory, there's a configuration objects that you can pass into the Realm instantiation method, and that means you can save it to wherever you want. Like if you want to make it a cache, save it to the caches, or to application support, you can do that. And another cool thing is you don't need to save your own reference to it. Like if you keep calling that one on whatever thread you're calling it on, it internally recycles pre-created references, pre-created objects. So it's very efficient and makes sure you write less code in order to actually reuse the same object. And the other one is the object, yeah. And that basically represents a single entry in your database. It supports all the major data types, strings, most types of ints, int32, 64, doubles, booleans, data. On the iOS side, it stores NS dates as well. And just like Realm, I forgot to mention, it's strictly thread confined, so you can't move these things across threads, but I'll talk about how you can get around that in a little bit. Next, we have basically what I want to say is Realm really strictly enforces this write transaction model. Once you've added an object to a Realm, you need to make any changes to it inside a write transaction. And this is done to ensure that there's no possible conflicts of background threads writing at the same time. Only one write transaction can be open at one time. Any other ones done on the background will be paused and made to wait until the first one is complete. But this means that we can guarantee that writes will be atomic and everything will be sent to disk properly. And then getting the data back out again is just as flagrant amount of code. It's basically, you get the same reference to the realm object, and then you just grab all the objects of that particular type, and then you just grab the one you want. And the great thing about realm is because it uses that zero copy paging mechanism, you're not actually grabbing every dog object on disk and bringing it in, you're just making a kind of like a weak reference to it and then pulling in the one you want. And this can actually be refined further. You can chain that all objects method with filter and sort, and filter uses the NS predicate string format, so you can then actually do really nice queries to actually pull out only the data you want in one transaction. So when you do one of those objects calls, what you get is called a realm results object, and they behave exactly like an array. So there's nothing crazy there. You can iterate through them like an array. You can pull objects out like an array. And when you pull an object out, that is when it gets loaded. So if you can actually have a giant, huge, thousands of objects in a results object, but if you only touch the first one, only the first one gets touched. So it's very efficient in the way it uses memory. And again, it's really strictly thread confined. Basically, any object that pulls data from a realm will have that realm as a parent property in it, and when that happens, like every realm only works on one thread at a time, so that any child objects are constrained to the same thread as that object. And like I just said, so it's a zero copy architecture. Like it tries its best to just point things to its properties on disk. It's very straightforward and very easy. Yeah, it uses memory mapping. Back in the old days, we were constrained by, sometimes we were constrained by the read speeds of SSD, of the NAND flash, but these days, especially the later iOS devices, we've actually found out parts of our own code are being bottlenecks because NAND flash has gotten really fast. So you're not getting any performance hits with this memory mapping technique. And as a result, you don't have to worry about pagination. So unlike SQLite or Core Data, you can just grab it all and then work on it as you want, and it's really nice and clean and a lot more minimal code. But the coolest thing about Realm is basically this thing called live updates. So this is really cool, and this actually makes it a lot less code. If you query for an object and you have a results object and then make a change subsequently, for example, this one is if you make a query for an object, a dog of age less than 2, if there's none in the database, you'll get an object. It won't be nil, but it'll be a count of 0. But then if you add one and then try the exact same object without refetching or refreshing or anything, it'll just automatically update. So this is really nice because it means that you actually don't have to worry about manually polling for changes in the background. When something happens, you'll be notified of it straight away. If you want an explicit notification call, like for example, if you've backed this to a table view and you need to update the table view, we provide a lot of different ways to register for these notifications, like KVO, which is also good for functional reactive programming. A general one that gets called every time a change happens to a realm, and a more fine-grained one where you can actually bind it to a table view. So as the data of a table view is changing, you can animate the table view appropriately. Cool, okay. And best practices. Okay, so this is some of the cool things. So that was a crash course in how Realm works. Now let's talk about some of the things that makes it work really nicely. A lot of people in Stack Overflow still think it's like SQLite. We have this copying mechanism, you have to refresh. So the one thing I really want to have everyone take away if you're using Realm is take advantage of live objects. Don't implement any kind of refreshing logic or re-querying. You don't need to do that. This is not SQLite, or Core Data, thankfully. So like I just said, you don't have to worry about any refetch code. That's not necessary. And yeah, so pagination is also not necessary. One thing some people do is they want to try and do their own custom filter, so they'll copy the results to an NS array or an array. That's not a good idea, because as you do that, you're actually then pulling everything into memory because you're accessing it all, and then hanging on to it with a strong reference. So we recommend if you can kind of create the filter you want with a Realm results object, you'll get much better performance. And make sure you take advantage of you can do your own NS notifications or whatever, but we recommend you take advantage of the notification system to be properly alerted when a realm has changed and you want to update your UI. Number 2, write transactions. So you saw what a write transaction is. It's just a simple closure, realm.write. But the thing we really want to recommend is you have to make sure, we don't have to, but we recommend you try and minimize as many as you want. So a pretty innocent looking bit of code here is you're basically going through a for loop and you're actually modifying a value for each iteration of the for loop. The problem is, because the realm write transaction's inside the for loop, what you're doing is you're opening and closing a write transaction every single time the loop iterates. And so what you're doing is, if you have 1,000 objects, that's 1,000 write transactions. So it's a lot more efficient to try and batch them together. And in this case, that's wrong. In this case, it's a lot easier if you just put the loop inside the write transaction. Now that's only one write transaction, so the write to disk will be a lot more efficient. So that's something something we really recommend, and it's a question on Stack Overflow. Because if you do this wrong, sometimes the file size of the realm file, because there's so many write transactions hitting the disk, the realm file size expands quite a bit, and we've had a few issues, people saying like, why is that happening? And we're saying like, well, you've got to be more efficient with your writes. Another thing we mentioned is, because it's only possible to have one write transaction open at once, if you have a big background operation and you try and do a write on the main thread while that background operation is happening, that will block the one on the main thread. And if you do that, your UI will freeze. So we always recommend, it's not possible all the time, but if you can, to try and make sure that you do as many writes as you can on the background thread, and also try and keep them as small as possible so you're not possibly having these giant blocking operations. And that's basically what it looks like. It's very easy. Like, you just have to recreate the same realm instance on the background thread, and you'll get the same setup as on the main thread, so it's very straightforward. Okay. So working across threads. Like I said, realm objects and any of their child objects are not thread safe. They're confined to a single thread just to ensure that atomic rights are maintained. So basically what happens is, there is an internal list where every single thread has its own unique realm instance. But basically what that means, if you want to pass an object between a thread, if you try and do this, if you create a dog object on the main thread, pass it to the background thread, and then try and access a property, it will trigger an exception straight away. And that's also a nice thing, because it means you know exactly that you're doing something wrong. So instead, what we recommend is you can use this thing called realm primary keys to have a way to uniquely identify a realm object. In this case, what we can do is have an ID property with a UID string. And then there's another method called realm get object for primary key, and you can just pass that primary key across the thread and then requery it on the secondary thread. And because the primary key property is indexed, it's very fast to look this up. So this works really quickly, and it's the best way to offload work to background threads. All right, finally, the new hotness that we've been working on this thing for 2 years. They were talking about this when I joined the company, and they've been working on this ever since. It's the realm mobile platform. So we announced this on September 26th, I think, so it's not even been a month at this point. And the basic concept of the realm mobile platform is, we live in a world now where people just assume that data is ubiquitous. You make a change on your iPhone, you want the same change to appear on your iPad. Now, most users expect this these days, because Apple's basically said iCloud makes everything synchronized. But in reality, this is still a lot of effort for developers. So the goal we're trying to do with the realm mobile platform is to make it so data ubiquity is very easy, but at the same time, it's also very seamless, and it just works for the users. So basically all this really is we have the mobile database component, which I just talked about, and now we have this new thing called the realm object server. So that's a binary that lives on a server. It can be Azure services or Amazon or DigitalOcean, basically anything that can run Linux or Mac OS. And basically, I'll show you the example video we have on our website. The goal is basically you can have two completely discrete devices making changes to one database. So when you write to the database locally, those changes are then transmitted over WebSockets to an equivalent data realm file on the server. And so basically what we're trying to work with is complete data parity across devices in the server. But what is really cool is it has a lot of really complex conflict resolution in here. So as you can see, even when the one on the right loses connectivity and still keeps persisting changes, those changes are buffered to the disk and still made. But then when the network connection comes back, those changes are then transmitted back up, and then the data reconciliation basically merges those things without any conflicts. So let's see, put it back on. There we go. It's back to Wi-Fi, and you'll see on the left-hand side the changes will then come across. So it's, yeah, we're pretty proud of it. And the basic thing we're trying to do here is we want to eschew the concept of a REST API. So the reason why REST API is necessary is because the way data is saved on device is usually different to how it's saved on the server. So what you need is some way to abstract the data between those two points. So usually what the model is you pull the data out of your local store, change it to an abstract format like JSON, transmit it up, re-serialize that into whatever format you need, and then save it to your online store. But in the concept of Realm, if the way the data is being saved is exactly the same on the server as it is on the local device, all you really need to do is just transmit the deltas of what actually changed. It doesn't even have to be JSON, so it can be binary data, and then that can be compressed really efficiently. So you get a really nice kind of automatic and much more less codey kind of way of persisting data. And obviously that's not obviously that means REST APIs they're still needed, but at the same time, when you have just a very simple model of transmitting data between just a server and a device, you can, if you don't need that extra data abstraction, this is a really efficient way of doing it. So basically, there's not much in the API. Like it's actually like an extra 2 lines of code. So I'll just talk about how it works really quickly. Basically, all you really need to do is when you're working with the Realm configuration object, you authenticate a user. There's not enough time to talk about how that works, but basically we provide a different series of mechanism options like username, password, a Facebook authentication, Twitter authentication, iCloud user identification. So you can authenticate a user, so you know that this is their device, and then all you have to do is hook it up to whichever server you've got the Realm object server running on, and that user. And then from that point onwards, if you do any write transactions, the data is just automatically sent up in the background. So you don't have to do any kind of manual code, no data transforms, no anything. It's just that's all there is to it. And obviously that means that the recipient device has to also acknowledge that a change happened. So how do we actually do that? Well, we actually do it the exact same way as we've been doing it from background thread updates. You can use the same KVO, the same general notification blocks, or the same fine-grained notifications to be alerted exactly when a change has occurred from another device. If you want to try it out, it's all on the website. We have a lot of tutorials and descriptions on how to get working with it. There is a free version for developers, and we've got a more hardcore enterprise version that we're working with a lot of clients. Basically, the enterprise version gives you a bit more online server access. At the moment, the developer edition just gives you the synchronization capability on device with the assumption you can do any business logic you want on the device itself. And we're still tailoring the enterprise edition at the moment. So that's on realm.io/pricing. But yeah, anyway, thank you very much for watching. I hope that was enlightening, and please give it a try. Have any questions? Hello.
Hi.
Whoa. Hello.
Just wondering if I'm just wondering how scalable this Realm object server is.
So at the moment, we've benchmarked it up to I think it was either 10,000 or 100,000 users. We've done a variety of internal tests. So that's one node, and we're actually working on ways to introduce a load balancer at the front, so you could then break up the load to different servers.
Can you do like sharding and clustering and stuff like that?
Sorry?
Can you do like sharding and clustering and to break it up to different servers?
We haven't got sharding at the moment, but we're working on that.
Oh, cool.
Yeah. I thought you said I was shouting. There's one off to the left over there. I've never seen that man in my life before.
Sorry, different question than the one I prepared you for.
Oh, you traitor.
I know. You answered the other one, so I had to think of something else.
Oh, dang, okay.
So a lot of your problems with SQLite and core data seem, well, I got the impression that they were due to best practices not being formed for that yet. If, have you tried things like magical record or any sort of abstractions around core data? And have you sort of tried core data again with sort of more modern practices?
So the answer is yes. So basically, I think, what was it, version 1.0.1 of my app was just raw core data on my own. And I had a Twitter meltdown at that point. And a lovely guy called Tony Arnold recommended I try magical record. So I tried that. That fixed 80% of the problems, but at the same time, there was still that little issue where, like, I think the biggest problem with core data is it's not thread safe, and it never lets you know it's not thread safe. So a lot of my issue was, even with magical record, it was getting really frustrating that even though I was following all the tutorials, I read the Apple documentation, I thought I was doing everything in best practice, but at the same time, I was still having troubles. And the problem with that point is it gets to the point where it's like, is it me? Am I just a bad programmer, or is this just a really bad framework? So it got to the point where I was like, I'm just spending so much time trying to make this work that I feel like there's got to be a better way out there.
One more question.
One more question. Hello, Ben.
Hello. Are there any best practices around using like Realm objects for, saying, writing like a document? So instead of like a dog, you have a document where you're updating text as a user is typing it, or is that just? Do you understand what I'm asking?
How do you mean a document? Like an external file, or just inside?
Oh, sorry. If you're working like with a document-based application, say
Okay,
like a notes application, and,
Okay, yeah,
and as you're writing, you want to keep saving the note so that you have updates. And I just saw you were talking about the loop there, where you kept you kept writing something.
Yep.
Or it might have been
The drawing up.
Right. When you have lots of writes, are there any best practices around that?
Yeah, well, the way the drawing app works is it's basically that. It's a ton of writes. Every time the Apple Pencil's going over the screen, it's literally every frame saving the X and Y coordinates of where the pencil was at the time and writing that to Realm. So that was a combination of a ton of writes happening concurrently and the conflict resolution merging those two changes together.
Thank you, Jim. Thanks.
Cool. Thanks a lot, everyone.